When you click on the Add File Excel icon, Excel immediately opens up the walk forward average file as you see here. In the column A are all the different filters that the walk forward metric explorer went through. For instance, the top filter, because this is sorted with respect to total out of sample net profit, the top filter was the bottom 20 total losing bars after we filtered out all profit factors that were less than or equal to 4. All profit factors that were greater than or equal to 4, all losers in a row that were greater than 5, and then all R2, R squared correlation coefficients that were greater than 90. Then after that initial screen that I showed you on metrics 1, 2, and 3, whatever number of rows that were left, it took the bottom 20 total losing bars, and so there was 20 rows left. Out of those 20 rows left, it looked at the other Power Walk Forward to optimizer metrics and chose the best EQ2V, which is if you fit a second order curve to the equity, and you look at the velocity of that second order curve at the end, that would be equity 2V. So it chose that, and the various metrics that it gave was the total out of sample gross profit, which was $43,709. The total out of sample net profit, which was if you subtract the $20 commission from each trade and add up all the pluses and minuses, you get 37,089. Now the average out of sample gross profit per week traded was 277. The average out of sample trade, given all the trades that it did, was $132. And these are gross numbers. In order to get the net, for each trade you subtract the $20 here. The average number of trades per week was 2.1, and the standard deviation of the weekly net profits, gross profits, was 756. T is a student distribution that looks at the weekly out of sample gross profits and the standard deviation, and it's a measure of whether those series of out of sample gross profits are random or not, and the higher the student T, the less the probability that it's random. OW divided by OL is if you take the average out of sample trades, winning trades, and you divide it by the average out of sample losing trades, the average wins was 1.45 times the average losing trades. The percentage of winning trades out of all the trades was 56%. The percentage of out of sample weeks that were positive after you traded during the week was 61%. The largest losing trade of all the trades was minus $1,525. The largest losing week was minus 1963. And the largest drawdown from the equity curve was minus 2656. The number of winning periods in a row, or in our case, the number of weeks in a row that it was positive was 12. The number of weeks in a row that it was negative was 5. The number of weeks that this metric filter actually traded was 158. So it didn't trade every week. It only traded maybe half the time. If you fit a straight line to the equity curve, the straight line trend is $145 per week. Equity V squared is if you fit a second order polynomial to the equity curve, and you look at the velocity at the end, it was 163. Deviation squared is the deviation from a straight line, the equity curve from a straight line. At each point on the equity curve, if you take the difference between the equity curve and a straight line fitted to the equity curve, you square it, you sum all those numbers, take the square root. This is a measure of how close the equity curve follows a straight line. So the smaller this number, the better off you are. K tau is a measure like the coefficient of correlation, except that it doesn't use any values. It's independent of the values. What it does is it sees how smooth the curve is. If a curve is very smooth, no matter whether it's a straight line or moving up or moving down, if it moves down, that'd be close to zero. But if it's moving up in a smooth manner, then k tau will be high. Of course, equity r squared is the correlation coefficient of a straight line fit to the equity curve. In this case, it's pretty high. Below is the total number of weeks that the equity curve failed to meet a new high. So, I mean, the maximum number of weeks that the equity curve failed to meet a new high, in this case, is 29 weeks. Excuse me. The break-even is basically any curve that has noise, any set of profit and losses that have a lot of noise associated with them. That's why they're going up and down. Sometimes it's profitable, sometimes it's loss. Can generate many different equity curves. Some end up below zero, some end up above zero. So this number says how many weeks would you have to trade to be assured that 90% with a 98% probability that your net equity will be above zero at the end of 304 weeks. The probability is just that. This compares the profitability of the filter to the profitability of the random selection. By random, I mean this number here is a bootstrap number. By that, I mean on each one of the files, each one of the 304 files, if we, instead of choosing a row that's been designated by any given filter, we chose a random row, and we choose a random row in each of the 304 files, so that we have 304 random picked out of sample net profits, and we add them up, and we would have a total random out of sample net profit. If we do this 5,000 times and then take the average, then we have some average random total out of sample net profit. If we divide by 304, then we'd have the average weekly random total out of sample net profit. In this case, it was minus $113.04 with a standard deviation of 65. So what this number represents is if I divided the total out of sample net profit 37,089 by the number of times it traded, which was 158, I compared that average to the 113.4 and with a standard deviation of 65. I probably get out there at 5 standard deviations for this number, which gives you a probability of 4.4 times e to the minus 08, 10 to the minus 8. But we're not done here. I mean, even though this is highly unlikely that this is this 37,089 was chosen by chance. I I did do 43,200 filters. So in order to find out how many random choices could beat my 37089, we will multiply 43,200 times this probability, and that would give you the number of random picks that could be better, equal or better than our particular filter. In this case, I mean, it's an infinitesimal number, so we can be assured that this is not this number that we got wasn't random. Of course, this all assumes that that the set of numbers that we have from the filter follows a probability curve that has a finite second order or standard deviation or a finite mean. If it's like a some of those probability distributions that don't have a standard deviation, like the black swan effect, then of course it doesn't matter what this number is or this number, because it's not a normal probability. So that effectively tells you what all the metrics mean. Now, if I highlight this line right here, which is my best pick in the paper that I mentioned earlier, and I go to add-ins, right here I have a XLA file that is also included with the Walk Forward Metric Explorer product, and I click on it, and it immediately shows the equity curve that is generated by all these numbers. The blue line is the equity curve without commissions. The red dots are the new highs. The brown line is the equity curve after commissions, and green dots are new highs. So this, I fitted a, let me move that out here. I fitted a straight second order polynomial to both these lines, and as you can see, the R squared is very, very high. This also gives you basically the what each trade, out of sample trade, is for each particular week. So for this particular week that ended on 8/5/11, there was a total out of sample profits at 175. There was 4 trades. The equity is a running sum of this. The net out of sample profit was 95 after subtracting 4 times 20, and this is the net equity. And these numbers were the inputs to the strategy that the filter that was run on the in-sample data said to use on the out-of-sample data. We'll cover that a little later on exactly how you do that. So it runs through each one of the 304 files. As you can see, there's a number of cases where it's 0. What that means is just the filter on the in-sample data simply did not find a set of values that satisfied it, so it came out 0, which meant don't trade that week, because I couldn't find a set of input values that satisfied our in-sample filter. Basically, you can choose any line, at random, and see what its equity curve is. I mean, you can do this over and over and over again, and it will tell you the exact information for that particular filter. So this is the output that you see, and this is the filter that you would use on for trading. Shortly, I'll show you exactly how to do that with another XLA file. In other words, you would run the Power Walk Forward Optimizer on the current week, which would generate all the in-sample value, and then you would run the next XLA file that I show you on that Power Walk Forward Optimizer output, and it would pop up with the inputs to the strategy that you should use to next week with your next week trading.